Hello, everyone, and welcome to Precalculus. Today, we are going to continue our study of the unit circle, which is a combination of sections 4.2 and 4.4. So this first page is just a review from yesterday or from last class, and I really just want you to see if you can fill it in. You really need to know this information by heart, not so much in college prep because you're not allowed an appendix, but because it would be like trying to do a math class without knowing 4 times 6. If you had to turn to your calculator every time you wanted to do something simple, it's just going to be really, really challenging. So you can go ahead and try and fill that in. So pause the video, go ahead and fill it in. All right, and I did go ahead and fill it in if you would like to check it. But we're going to go ahead and pick up right where we left off yesterday with some examples. Just because I know this is hard and I want to help you get good at it. So when I am asked for sine of 4 pi thirds, my first thought is, okay, well, the reference angle is pi thirds. And I look on my chart and I see that sine of pi thirds is the square root of 3 over 2. So the only thing that I have left is to decide if it's positive square root of 3 over 2 or negative. So you do have to know where this is. 4 pi thirds, if you look at your unit circles in quadrant 3, or if you don't have your unit circle handy, you should be able to think of this as 1 1/3 pi. And since this is pi, 1 1/3 is a little more than pi. That's why it's in quadrant 3. And sine is negative in quadrant 3. So if you don't want to watch this entire section, obviously you don't have to, but I'm going to go through each one, hoping that it'll help you understand it. The next one, I look at 3 pi fourths, and I think the reference angle is pi fourths. I look at my chart. Cosine of pi fourths is the square root of 2 over 2. Cosine in well, first I need to figure out the quadrant. So 3 pi fourths is in quadrant 2, and cosine is negative in that quadrant. Tangent of 7 pi 6. The reference angle is pi 6. I look on my chart and I see that tangent of pi 6 is the square root of 3 over 3. And for people that are trying to memorize it, I'll just tell you how I do that. Tangent of pi 6 is square root of 3 over 3, and tangent of pi thirds is square root of 3. And the way I memorize that is the 3 and the 3 is needed to make the 6, where at pi thirds there's just 1 3. I don't know if that'll help you, but that's how I have them memorized. So 7 pi 6, again, that's a little more than pi. So that's in quadrant 3, but tangent is positive in quadrant 3. Oops. So you are good to go. The next one, sine of 5 pi fourths. The reference angle is pi fourths. I love the reference angle. It's so easy. Sine of pi fourths on my chart is the square root of 2 over 2. 5 pi fourths is in quadrant 3, and sine is negative in quadrant 3. Notice the repetition of steps that I'm doing. Cosine of 11 pi 6. The reference angle is pi 6. I look up on my chart and I see that cosine of pi 6 is the square root of 3 over 2. 11 pi 6, you can look at your unit circle, or you can think about it that 12 pi 6 is 2 pi. That would be all the way around. So I'm just shy of that. So I'm in quadrant 4, and cosine is positive in quadrant 4. Tangent of 5 pi thirds. The reference angle is pi thirds. Tangent of pi thirds is the square root of 3. And 5 pi thirds is in quadrant 4, where tangent is negative. Cosine of negative 60. See, this is where it gets a little tricky because degrees aren't as fun. So negative 60 is here. It means you've gone in this direction. But that triangle that it's going to make would be the same as if we had gone 60 in the positive direction. So I can think of this as just a reference angle of 60 degrees. So cosine of 60, this is the same as pi thirds. I guess we didn't actually do that on your chart, but if you would like to go back and label it real quick, this is 30 degrees, 45 degrees, 60 degrees, 90 degrees, 180 degrees, and 270 degrees. So pi thirds is 60 degrees. And which one are we looking for? Cosine of 60 degrees is 1/2. And negative 60, the original angle, is in quadrant 4, where cosine is positive. Good. Another radian measure. Very easy to find the reference angle. It's pi 6. Tangent of pi 6 on my chart is square root of 3/3, or if you have it memorized, the 2 3's make 6. And 11 pi 6, we already talked about this, how 12 pi 6 is just about all the way around. So 11 pi 6 is going to be right there. So it's in quadrant 4, and tangent is negative in quadrant 4. You know, I've been assuming the whole time that you know which quadrant is which. Maybe we should just review that. 1, 2, 3, 4. All right, cotangent of 410. All right, this one's hard for so many reasons. First, it's in degrees. Second, those degrees are bigger than 360. It's gone around. So I'm actually going to take 410 and subtract 360. Oh, but then I get 50. 50 is not one of our known angles. So when you get something that's not known, you can use your calculator. I do not expect you to get the exact answer. So this is what we call an exact answer. You'll see your book say, find the exact value. They say that because if you use your calculator, you would get 1.7 something, 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 and you would probably round. You would definitely round it. You can't do all the decimal places. So this is what I mean when I say exact. Pretty much you can't use your calculator. But now you can use your calculator because we're only expected to know the ones on the chart. But like I said, as if this problem wasn't tricky enough, now it's a cotangent, which isn't on your calculator. So you are going to have to use the property that cotangent is the reciprocal of tangent. So I'm going to write this as 1 over tangent of 50 degrees. And that you can do on your calculator. Literally, just make sure your calculator's in degree mode, and then go ahead and do that. And I don't actually have the answer, so allow me to do that too. 1 divided by tangent of 50 is 0.839. I still have to determine whether it's positive or negative, but when I went all the way around to 410, it landed me in quadrant 1, and they're all positive in quadrant 1. Sine of 5 pi thirds. The reference angle is pi thirds. Sine of pi thirds is square root of 3/2. And 5 pi thirds is in quadrant 4, so it's negative. All right, we have 4 more to practice on. Secant of pi ninths. Again, I don't know I don't know the angle pi ninths. It's not one of the ones that I have memorized. So I am allowed to use my calculator, which at first you might be like, yay. Not really. I'd rather just look at the chart. And secant's not on my calculator. Non-yay. So I have to know that secant is the reciprocal of cosine. And now you're going to have to switch the mode. We just had it in degree mode in order to do that 50 degrees. And now I need it to go back to radian mode. So I hit the mode button, which is next to the second button. I go down and click on radian. And now I can do 1 over cosine of, there is a pi button. It's above the caret key. Make sure that you don't just do 3.14. Pi ninths. And I get 1.064. Pi ninths is in quadrant 1, so it's positive. You'll notice that I've been putting all the little positives in. It's not that that's required. It just helps you know that you actually took the time to figure out if it was positive or negative. Okay, so I'm trying to do a couple tricky ones here at the end. Again, if you always want to try them yourself, that's the best policy. So cosine of 5 pi. So there's 1 pi, 2 pi, 3 pi, with me, 4 pi, and 5 pi. So 5 pi is the same as pi, and we call that coterminal. So cosine of pi, according to my chart, is -1. So that one isn't in a quadrant. That's why those are on your chart, because these are on the quadrantals. So those are called quadrantals. So I had to give them to you because you can't use the forecast because they're actually right on the quadrant. Good. A nice easy one again. The reference angle is pi 6. Sine of pi 6 is 1/2. All you need to do is figure out if it's positive or negative. Now I did make it harder. I made it 19 pi 6. So right away you can subtract 12 pi 6 to get the coterminal, because that will send you back a whole loop around. So wherever you are, if you subtract 2 pi, you've gone one whole circle around. So now I'm at 7 pi 6, which is in quadrant 3. Here's 6, 6, 7, 6 would be right there. And sine is negative in quadrant 3. And the last one, again, making it more difficult now by making it negative. So normally 7 pi 4ths is here, but since it's negative 7 pi 4ths, I have to go backwards. So I'm going to go like that, and I get to negative 7 pi 4ths that way. Its reference angle hasn't changed. It's still pi 4ths, and tangent of pi 4ths is still 1. But you needed to know what quadrant negative 7 pi 4ths landed in. And since it landed in quadrant 1, it is positive. Okay, moving on. Number 15. Let -3, 4, so let me draw that. 1, 2, 3, 1, 2, 3, 4. -3, 4 be a point on the terminal side of theta. So there's my theta. So I know I'm in quadrant 2. Find the sine, cosine, and tangent. So now we're going to be combining a couple things that we've learned. Well, first of all, quadrant 2, this is positive, this is negative, this is negative. I'm already halfway there. The second thing we're going to do is we're going to use the definitions we haven't used in a while of opposite and adjacent. So this is a little confusing. This is going to be our reference angle. Even though this is the theta we're referring to, we're going to use the blue theta to get the answer. That's always what sine, cosine, and tangent refer to, is the theta that is closest to the x-axis. The positive and negative account for the fact that it's not actually that angle. So since this is the point -3, 4, this distance is 3, -3 technically, and this distance is 4. This is a Pythagorean triple. It is a 3, 4, 5. If you don't have that memorized, that's okay. You can do 3 squared plus 4 squared is equal to hypotenuse squared, and you'll get that the hypotenuse is 5. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now, there is a second way to do this problem, and that is some people don't think about forecast. You'll notice that I did the signs first based on the quadrant, but you didn't actually need to do that if you label correctly. This is technically -3 because it's in this direction, and then this is 4, and this is 5. The radius is always going to be positive, and the hypotenuse is always going to be positive, but this is positive because we've gone up. So if you look, sine is +4 over +5. Cosine is -3 over 5. And tangent is -4 over -3. So -4/3. So interestingly, you could have gotten the positive and negatives just from your triangle if you want to take the time to note whether or not the 4 and the 3 are positive or negative based on your picture. But since you've already learned forecast, and since we knew we landed in quadrant 2, I just used that. The best thing is to use a combination and kind of use it as a double check. All right, so let's put our thinking caps on now. Now it's not telling me where this point is. It's just telling me that tangent is -5/4. So where am I going to draw it? It's negative. So I'm either going to draw it, according to forecast, in 1 or 4. But it says that cosine is positive. So it's not, did I say 1 or 4? 2 or 4. But it's not going to be in quadrant 2 because cosine's negative there. So this information tells you you're in quadrant 4. Okay? Which means right away you might want to do this first. Sine is going to be negative, and secant, which goes with cosine, is going to be positive. So go ahead and draw your triangle. Remember, always draw the theta next to the x-axis. Tangent is opposite over hypotenuse. Now, it came out to be negative. So which one of these two is negative? Well, just based on the fact that this is the x-axis and this is the y value, the 5 is definitely the negative. Does that matter when you're doing your hypotenuse? Yeah, 4 squared, because -5 squared or +5 squared is going to come out the same either way. So 16 plus 25 is equal to h squared. 41 is equal to h squared, so h is the square root of 41. So sine is opposite over hypotenuse. Now I can't leave it like that. I'm actually going to, instead of writing it slanted, I'm going to write it upright. It'll help you see how I clear the, rationalize the denominator. So I'm going to multiply the top and the bottom by the square root of 41. And that gives me -5 square roots of 41 over 41. That negative can go out in front or it can go on top. Most people don't put it on the bottom. They just move it to the top. The only reason that that's sometimes better is because sometimes when you write it out in front, if you write it too close to your fraction line, you'll lose it. Secant is hypotenuse over adjacent. No rationalizing of the denominator needed. Number 17. And like before, the more of these you try on your own and then watch the video, the better. Let theta be an angle in quadrant 2. So this time they gave me the quadrant. These are all like little puzzles. I personally love them. Such that sine, so I'm going to draw a triangle. And remember, here's my theta, not next to the y-axis, next to the x-axis. And sine is opposite over hypotenuse. So opposite over hypotenuse. I do need to find that third side. So I'm going to just call it x temporarily. X squared plus 1 squared is 3 squared. X squared plus 1 is equal to 9. X squared is equal to 8. X is equal to the square root of 8, but you should really break it down into parts you can do and parts you can't, so you can write it as 2 square roots of 2. Find cosine and tangent. Both cosine and tangent are negative in quadrant 2, and cosine is adjacent over hypotenuse. Done, because the radical is on the top. Tangent is opposite over adjacent. Not done, because the square root's on the bottom. So I multiply by the square root of 2 over the square root of 2. And I get -√2 over, so these two, square root of 2 times the square root of 2 is 2. So now I get square root of 2 over 4. Okay, so like I said before, you can do these differently in the sense that if you don't want to use forecast to get the sign, this actually must be negative, even though I know we got x is 2 square roots of 2. Because of the side of the axis that it's on, it's definitely negative, where the 1 is positive and the 3 is always, the hypotenuse is always positive. So then that's another way you could have gotten the -2 square roots of 2 over 3 adjacent over hypotenuse, and it would have made tangent negative as well. So a nice little cross check there. Number 18, let theta be an angle in quadrant 3. So I'm going to make my triangle. there's my theta next to the x-axis, such that sine of theta is opposite over hypotenuse. Now, the negative could have gone this way. You don't really know, just because when you have negative 5 over 13, that could be 5 over negative 13. They actually are equivalent. So how did I know where to put the negative? I put the negative with the down one because the hypotenuse is always positive, and because this is going down on the x-axis. So this is a Pythagorean triple. If you don't have it memorized, then you're going to have to do it out. So negative 5 squared plus x squared is equal to 13 squared. 25 plus x squared is equal to 169. X squared is equal to 144. X is equal to, so technically plus or minus, right? So which one do we want? We want the negative 12. Is that helpful? Not to me, because I personally, when I'm asked for secant and tangent, I just think to myself, well, tangent had better come out to be positive and secant had better come out to be negative based on the forecast, right? Remember, secant goes with cosine and tangent has its own spot. And I expect tangent to be positive. But just to show you that that works, opposite over adjacent. And sure enough, it did come out to be positive. So I feel really good about that answer. Secant is hypotenuse over adjacent. Although nobody writes it that way. Just either negative 13 over 12 or negative 13 twelfths with a negative out in front. Number 19. Okay, so this is back to a repeat of the one that we did before. You definitely, if we were in class, I would not be doing all these problems. You would be doing them on your own and I would just be walking around checking. So try and do it on your own. But I'll do it out for you in case you got it wrong. So let negative 2, 3 be a point on the terminal side. There it is, negative 2, 3 of theta. So if it's the terminal side, that technically means theta is here. But in trigonometry, these sine, cosine, and tangent will always refer to the green theta. It's the positive and negative that will make you know that it was the black one. But we use this one as the reference angle to get the answer. So since it's negative 2 and 3, this distance here is negative 2, and this distance is positive 3. This is not a Pythagorean triple like this one was, 5, 12, 13. So far we have 3, 4, 5, 5, 12, 13, just some ones to know. You can keep a little list for yourself on your appendix. But this one's not. So now I could write negative 2 squared, but I know it's going to come out to be positive. Plus 3 squared is equal to the hypotenuse squared. 13 is hypotenuse squared. Hypotenuse is the square root of 13. Not plus or minus, it's always going to be positive. I mean, in this equation, it's plus or minus, but we're going to use the positive one. And now I can do sine is opposite over hypotenuse. It came out to be positive, which I expected because I'm in quadrant 2. I do have to rationalize the denominator. You don't actually have to show this step. You're going to do so many of these that you'll be able to get from here to here in your head, and that's fine. Cosine of theta is adjacent over hypotenuse. It's negative, which I expected because cosine is negative in this quadrant. And now you see why cosine is negative in this quadrant, because cosine is dependent on this value. And it's over on the left-hand side. That's what makes it negative. Where sine is dependent on the y value, which is positive in quadrant 2. And this gives me negative 2. Like I said, you can probably skip that multiplying the top and the bottom by the square root of 13. And tangent. I expect it to be negative because it's quadrant 2. And sure enough, opposite over adjacent, although nobody writes it that way. Number 20. given that sine is equal to 4 over 5, so I could start to draw the triangle right away. This is acceptable to me. Opposite over hypotenuse. Hopefully you recognize that this is a 3. But then I've just assumed, or I've just drawn it in quadrant 1. But then I read that tangent is negative. So when they give you two pieces like this, use the two pieces of info to determine the quadrant. So you can draw the triangle that way if you want to, but if tangent is negative and sine is positive, I must be in quadrant 2. Now, some people really like to redraw it. They like to draw the correct thing. So opposite, adjacent, 5 for the hypotenuse, so that they can have everything correct. You're not required to do that. I personally don't do that. I personally just sit there and say, well, if I'm in quadrant 2, cosine is negative. Cosecant is based on sine, so cosecant is going to be positive. That's really the purpose of drawing it in the right quadrant. But if you kind of like, no, I really like having this labeled as -3 and this is +4, and then the hypotenuse is always positive, and then I can see it better, by all means, draw it in the correct quadrant. So cosine of theta is adjacent, there's my negative, over hypotenuse. Cosecant is the flip of sine, so it's going to be the hypotenuse over the opposite. On number 21, it says, let theta be an angle such that tangent of theta is undefined, and theta is between pi and 2 pi. Find all 6 trig functions. So my first goal is to figure out when tangent is undefined. If you look on your chart, you'll see that it happens at pi halves and 3 pi halves. Just as a little reason for that, remember that tangent is equal to sine over cosine. And therefore, whenever tangent, or rather whenever cosine is equal to 0, tangent is going to be undefined. And cosine is 0 at pi halves and 3 pi halves. But they've narrowed it down even further, and they want the theta between pi and 2 pi. And putting both of those pieces together, we rule out pi halves. Remember, on your unit circle, this is 0, pi, pi halves, and 3 pi halves. And then when you go all the way around, you'll be back at 2 pi. So the theta between pi and 2 pi is the 3 pi halves. So pretty much all of these pieces join together just to let you know that theta is equal to 3 pi halves. And that's what I mean by saying it's a puzzle. You're putting together all the knowledge that you have. Now the actual question is, find all 6 trig functions. So sine of 3 pi halves, it is a quadrantal. It's on your chart. Sine of 3 pi halves is -1. Cosine of 3 pi halves is 0. And obviously tangent of 3 pi halves is undefined. And then I'm going to put them right next to it because they go together. Cosecant of 3 pi halves is the reciprocal. The reciprocal of -1 is just -1. The reciprocal of cosine is secant. So secant of 3 pi halves would be undefined because if you flip that 0 to the bottom, you can't do that, so it would be undefined. The bigger question, though, is what happens when you flip an undefined? So it might be easier in this case, since we can't really flip undefined, to think about cotangent as cosine of 3 pi halves over sine of 3 pi halves, which is 0 over -1, which is 0. So there's different ways to think about things. Normally, I would think about cotangent as being the flip of tangent, but in this case, that wasn't convenient. But thinking about cotangent as cosine over sine is convenient. So there's a lot to learn in trig. Number 22, state the quadrant in which theta lies. So right away, when I see that I'm going to need to know something about quadrants, I'm going to go ahead and draw my forecast. It's called forecast because I'm going to start in quadrant 4 and then write the word cast. In case you still don't know them very well, this is quadrant 1, 2, 3, and 4. So it's starting you off by saying that sine is less than 0. That's another way of saying that sine is negative. So where is sine negative? Sine is negative in quadrants 3 and 4. Because what forecast means is that they are all positive in quadrant 1. Sine is positive in quadrant 2. Tangent is positive in quadrant 3. And cosine is positive in quadrant 4. So sine is negative in 3 and 4. But then this piece says where is cosine greater than 0, which means positive. And cosine is positive in quadrant 1, where they're all positive, and in quadrant 4. So where did that put me? Quadrant 4. Make sure you answer in Roman numerals. You should see if you can do letter B on your own. But I will do it for you. Sine of theta is greater than 0. That means positive. To be greater than 0 means to be positive. And sine is positive in quadrants 1 and 2. 1 because that's where they're all positive, and 2. And then tangent is less than 0, which is another way of saying where is tangent negative? Tangent is negative in quadrants 2 and 3 because they're all positive in 1 and tangent is positive in 3. So 1 and, I think I said 3 before, 1 and 4 is where tangent is negative. So the word and means both of these conditions are true. Sine is positive and tangent is negative. What quadrant am I looking at? Quadrant 2. They both involve quadrant 2. So in these last two, I called them bonus questions because I'm always so excited when kids figure them out on their own, but I'm usually walking around the classroom and saying, oh, go and try those ones. And I sometimes will offer a bonus for somebody that doesn't need me to explain it because you have the ability to figure this out. This is where I'm trying to bring you in math, is the ability to read something that I know you have all the knowledge for and put the pieces together. So it says the terminal side of theta lies on the given line in the specified quadrant. So the first thing you're going to want to do is graph that line. If it were to put the b there, it would be 1/3 x plus 0. So I'm going to start at 0 and then go up 1 and over 3. I can't keep doing that, but I can go down 1 and back 3, and I can make a nice line. Now you have to know the definition of terminal. So all angles start on the x-axis and they go around. And it says the terminal side of theta lies in quadrant 3. You have to know that this is quadrant 3. So therefore, this is the theta that I'm looking at. But keep in mind that when you're making your triangle, you want to use the reference angle. So the theta is actually just that little green one right in there. The theta is not the entire red one. What do they ask you to do? Find the values of the 6 trig functions. So I know I'm going to need sine of theta, cosine of theta, tangent of theta, and then I kind of think of it as a break because then when I do cosecant of theta, I can just flip sine. Secant of theta and cotangent of theta. So once you've done 3, the other 3 are easy. So how do I find sine of theta? Well, when I think about sine, I think about opposite over hypotenuse. But to think that way, I need a triangle. So you can make one. You can make it anywhere you want, except that you don't necessarily know the lengths of those sides, which isn't helpful. So instead, do it at the point that you do know. Based on slope, you were able to plot that 0, 0, and then that down 1, back 3. So this is 1, and this is 3. Using Pythagorean theorem, 1 squared plus 3 squared is equal to the hypotenuse squared. 10 is equal to hypotenuse squared. Hypotenuse is the square root of 10. So now I actually have a triangle. So sine is opposite over hypotenuse, which if you rationalize the denominator is the square root of 10 over 10. Cosine is adjacent over hypotenuse, which again, if you rationalize, is 3 square roots of 10 over 10. Real quick, if you still don't know how to do that, you are multiplying the top and the bottom by the square root of 10 in order to rationalize. Tangent is opposite over adjacent. And now you can just flip them to get these other three. Cosecant is the flip of sine, so square root of 10 over 1, which is just the square root of 10. You don't even need to show that step. Secant, the square root of 10 over 3, because I get to just flip cosine. So the more you know your definitions, the easier your work will go. And then cotangent is 3 over 1, which of course is just 3. Now, before I consider myself finished with this problem, I do need to put in the sine values, S-I-G-N. Remember that we're working in quadrant 3. And in quadrant 3, only tangent, and therefore cotangent, are positive. Sine and cosine are negative, which also means that cosecant and secant is negative. Another way to have done this problem would have been to put the signs actually with the numbers. If you think you're going to forget at the end, when you actually draw your triangle, you could make that a -3 because it's on the negative part of the x-axis. And you could make that a -1 because it's going down on the y-axis. Or you can just take care of the signs at the end. It's really up to you. So now you can try B on your own. But of course, I am going to do it for you. So again, to graph this line, it starts at 0. That's its y-intercept. And then the slope is down 4 and over 3. That's as far as I can go in that direction. So I'm going to go back 3 and up 4 in order to draw my nice line. It says that theta, the terminal side of theta, lies on the line, but not there, in the specified quadrant. So since it's in quadrant 4, I have to keep going. And that is my theta, that big, huge angle. So it's, 300 or so degrees. But I don't actually need to find the degrees. I'm actually going to be thinking about this little reference angle and drawing my triangle based on that. So this triangle is 3, 4, based on the slope. And because it is a Pythagorean triple, I don't have to do this step, but I could, if I wanted to, I could do 3 squared plus 4 squared is equal to h squared. But if you know the Pythagorean triples, 3, 4, 5 is one of the ones that you would be good to know. Now, I'm going to do this one a little bit differently because I want to show you back in number 1. So first, sine of theta is opposite over hypotenuse, so 3 over 5. But on this one, instead of putting in the signs in at the end, like we did before, I'm going to put them in now. Some people find they're more successful this way. So the 3 is positive because it's on the positive part of the x-axis, but the 4 is negative because it's down below 0 on the y-axis. When I do that, I don't know why I wrote 3 over 5. So when I do that, I get -4 over 5, which makes sense because sine is negative in quadrant 4. And this time, instead of doing sine, cosine, and tangent, I'm going to do sine and then cosecant right away because they go together. And then cosine is adjacent over hypotenuse, which means secant is hypotenuse over adjacent. And they came out positive, which again makes sense because I'm in quadrant 4. Tangent, I'm going to expect to come out to be negative. Let's check that out. Sure enough, opposite over adjacent, -4/3. And then cotangent, -3/4. Now I realize that when you go to do it, you're going to get 3 over negative 4, but nobody says that. You can either say negative 3/4 or negative 3 over 4. These all mean the same thing, but people don't usually write the negative on the bottom. Okay, that is it for today. Have a great day.